Hey guys! So today we're going to talk about how to find the area between two curves. So far we've been able to find the area underneath the curve and the x-axis, but how do we go about finding the area between two curves when you have something going on up here and something going on down here? So here is the mathy information. If y sub 1 and y sub 2 are continuous on A is less than or less than or equal to x is less than or equal to b, and y sub 1 is greater than or equal to y sub 2 for all x in A is less than or equal to x is less than or equal to b, then the area between y sub 1 and y sub 2 from x equals a to x equals b is given by the integral from a to b of y sub 1 minus y sub 2 dx. And that made zero sense, right? Okay, basically what they're saying is if we take these two functions, if we take the top curve minus the bottom curve, and we do the integral from those two x values, that will give us the area between those two curves. So today, since we really just want to understand this concept and less about, going through and doing definite integrals by hand, we're only going to do one of these by hand. The rest of them we're going to use our graphing calculator for. So, first thing, come on. You know you want to switch. There we go. We want to find the area between the curves x squared minus 2 and y equals negative x. So the first thing you want to do is you want to graph the region bounded by the curves, which basically means, hey, graph the situation, figure out what's going on. So x squared minus 2, that is my usual parabola, just shifted down 2. So now my vertex is down here, and I will graph the rest of this. Okay, and then we have y equals negative x. So that's a line where the y-intercept is 0, and then we go down 1 over 1, down 1 over 1. We'll graph that line. Okay. So what we're trying to do is we are trying to find, come on, here we go, this area right in there. That's what we're trying to figure out. So to figure that out, we have to write our integral. So remember, we need our integral from a to b. So first of all, we have to figure out what are a and b here. So a is the x value that is farthest to the left, b is the x value that is farthest to the right. So to figure out what this x value is going to be over here, that's going to be the intersection of those two graphs. So we have a coordinate there at negative 2, 2. So that means that my first x value is at negative 2, so that's a. And then I have values all the way till b. That's over here at 1, negative 1. So my b value then has to be 1. So I want the integral from negative 2 till 1. And then I want to make sure that I have the top function minus the bottom function. So I'm going to put some parentheses. So the top function here was my line, because that's the one that's above this guy. So my line is my top function, so that's the opposite of x. Minus. Now, life advice. We like parentheses. Please use them. So I'm going to put parentheses right here because I need to make sure that I subtract all of that bottom function, x squared minus 2. Good deal. So that is our expression for the area between these two curves. So now we're going to go through and solve for that area. Like I said, we're only going to do this once by hand. The rest of the day, everything is going to be on our graphing calculator. So here we go. Let's go ahead and simplify the inside. It's -2 and 1. If we distribute out that minus sign, we have a negative x squared. We had negative x from before. And then if we distribute that negative out, we have a plus 2. So we have all of that dx. So we learned how to do definite integrals yesterday. So the first thing we want to do is find the antiderivative of all of this. So when we find the antiderivative, remember we're going to add 1 to the power, divide by the new power, minus, add 1 to the power, divide by the new power, and then add 1 to the power. And then we want to evaluate this from -2 to +1. So now we'll go through and solve. Let's see, if we plug in 1, we'll have 1 cubed is 1, negative, and then over 3, so we have -1/3, minus 1 squared is 1, so that's 1/2, plus, and then 2 times 1 is 2. Good. Minus, and then we'll want to plug in -2. So -2 cubed is -8. So then I have the opposite of -8 is +8. So that's 8/3 minus, let's see, -2 squared is 4. So we have 4 over 2, and that's just 2. And then if we plug in -2, so 2 times -2 is -4. All right. So if we go through and simplify this a little bit more, let's see. We've got -1/3 minus 1/2 plus 2 minus 8/3 plus 2 plus 4. Okay, I'm going to group together what I can right now to make life a little bit easier. So if I put -1/3 and -8/3 together, that makes -9/3, which is just -3. And then I can group together my 2, 2, and 4. And let's see, that will make 8. And then I still have that -1/2. So let's see, -3 plus 8 is 5. 5 minus 1/2 is 4.5. So the area between those two curves is 4.5 units squared. Good deal. So we don't have to go through and do the definite integrals every time. From here on out, we're going to be using our handy dandy calculator. So here we go. Using a graphic display calculator, find the area between f of x equals 2 to the e to the negative x over 2, and g of x equals x squared equals, x squared minus 4x. So the first thing we want to do is we want to graph it out to figure out what exactly is going on. Like I said, we don't want to graph it by hand because it's just going to take too long, especially with E and all of that sort of stuff. We don't want to try to do that by hand, so we're going to use a calculator for that. So I went ahead and got this picture from Desmos a little bit earlier. I'm going to shrink him up to where he might be nice to use. I'm going to shove him in the corner, actually. Maybe I can make him bigger if I shove him in the corner. Ooh, he went wonky there for a minute. Okay, cool. There we go. So the red graph right here is f of x, and my blue graph is x squared minus 4x. So actually, let me select this so that way we can look at it for just a minute. So what we're trying to find is all of this area in between here, this little dippy part right here, and then it's cut off by that red part on top. So we're trying to figure out what this area is right there. So just like before, we needed to figure out where those functions intersected. So you can either find that on your graphing calculator, or we let Desmos do the job for us right here. Let's write our integral. So the x value where these two functions intersect first is over here at negative 0.584. So I'm just going to put it as negative 0.58. And then I have all of that area until they intersect over here at 4.064. Or what did I put in my notes? 4.6? I put 4.06, yeah. 4.06. Okay. And then remember, to find the area between the two curves, we have to take the top function minus our bottom function. So remember that top function up here was that red line, and that was my e to the x. So 2e to the negative x over 2 minus, and then please put some parentheses so that way we'll know that it needs to distribute that negative out to the x squared minus 4x dx. So this looks big and gross, and it is, but the good news is we have technology. So the technology will just do it for us. So what we're going to do is we're going to put in that function into y equals. So into y equals, I've got 2e to the negative x over 2 minus parentheses x squared minus 4x close parentheses graph. So it's going to give us a graph of something that honestly we don't really give two hoots about. What we want to do is we're going to go to second trace to get calc, and then go down to 7 to get that integral, just like we did before. They're going to ask for our lower limit, which is at 0.058, or negative 0.58. And the upper limit is at 0.06, or 4.06. Press enter. And then it will let us know that that integral is equal to 14, I'm getting 14.7419, blah, 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 blah. I hope you're getting the same thing. What also is pretty cool is like, hey, look, they'll even show you the area that's like colored in. Isn't that neat? I like that. My calculator didn't do that. The new fancy ones do though. Anyways, so that ends up being about 14.74 units squared. Good deal. So let's try one more. Okay, so using a graphic display calculator, find the area between these two curves. So f of x equals 10x plus x squared minus 3x cubed, and g of x equals x squared minus 2x. So the first thing we want to do is go ahead and graph these guys out in our graphing calculator. I'm going to go ahead and keep these pictures kind of large though. Try to slide it down a little bit. Maybe that's the way to go. Okay. So here's the thing. There are different sections on these graphs. So I have the area between the two curves in this part of my graph. And I have the area between the two curves in this part of my graph. So here's what you might be noticing. That green graph is on top for this pink area over here, but the blue graph is on top over here for this teal-ish area. So which one is the top, which one is the bottom? It switches. Okay, so here's what we have to do. We have to write two different integrals. One integral for where blue is on top and green is on the bottom, and another integral for where green is on the top and blue is on the bottom. So we're going to have to break it up into two separate guys. So we have to know where these functions intersect, and they're going to intersect at three different places. So they intersect right here at -2. They intersected right here at x equals 0. And they intersected right here at x equals 2. So when I write these integrals, one of them is going to have to be from -2 to 0, and the next integral will go from 0 to 2. So I need two separate guys. All right, so from -2 to 0, that's that green part over here. The top function there is my blue function. That blue function was my x squared minus 2x. So that's what's going to go on top. X squared minus 2x. Minus. So then the function on the bottom was that 10x minus x squared minus 3x cubed. So we want to make sure that we put our parentheses there for our 10x plus x squared minus 3x cubed. Woo! dx. And now we'll need another one from 0 to 2 to get the area of this pink stuff. So the top function there is my green function. So that's the 10x plus x squared minus 3x cubed. So that will go on top. 10x plus x squared minus 3x cubed minus, and then don't forget about those parentheses, so that way our negative will go out to everything. And that function on the bottom was that x squared minus 2x. dx. So then we will go and find our, okay, so I have another way for you guys to find integrals, so that way we don't have to go graph both of these guys. So here's what you're going to do. Okay, first thing you're going to do is you're going to click on Math. And then you see where it says FN int, that's function integral. So you're going to click 9. And then it'll look something like that. Oh no, my screensaver. Hang on. Nope, put in my password wrong. Okay, let's try again. There we go. Okay. I need to just turn off my screensaver already. Okay, so it should look something like this. So I'm going to go ahead and input my first integral, -2, 0. And then we have x squared minus 2x minus parentheses 10x plus x squared minus 3x cubed dx. Okay, so that's that first area, right? Okay, so I'm going to press enter, and that one is 12. Equals 12. Okay, that's hard to see. Equals 12. Beautiful. Okay, now we are going to take the integral. So once again, we'll go back into Math. Click 9 to get the integral, and then input all your information. 0 to 2 of 10x plus x squared minus 3x cubed minus parentheses x squared minus 2x dx. Good deal. And then we'll press enter. And then that's 12 as well. So the area of the green is 12 units squared, and the area of the pink is 12 units squared. So what's the full area between them? 24 units squared. Good deal. So next time we'll talk about more having to do with integrals and other things we can do with them. It'll be a ball. See you later. Bye, guys.